Hi guys, am I audible?
Yes, sir.
Oh,
Yes, sir.
So yeah, let's start the class at 10:05. Okay, 5 minutes of wait time. Okay, so let's start with today's session. Right, in the last session, we covered almost every problem of the 2D array assignment. The only problem left was a spiral traversal. Right? Let me just share my screen. All right, guys, is the screen visible?
Yes, sir.
Okay, guys, did you try the assignment questions on your own? Like any of you guys facing any problem apart from the spiral traversing a matrix? Like, did you guys tried the homework that I gave you in the last class? How many of you guys like tried it? I asked you guys to basically spend 30 minutes with an algorithm of like swapping, right? So did you guys did that? Okay, so those who did it, were you able to understand it now, how it is working and all, or you still guys face any doubts? I hope you guys tried like several examples to basically figure out how it's actually working, right? I don't see anyone like talking about the doubts, right? So yeah, I guess now most of you guys will be understanding how the swapping algorithm is basically working and what is the parameter n minus 1 minus I, right? So okay, so for today's class, let's basically start with this problem. Right? Okay, good. Voice is too low. Right, so guys, is it good now? Right, I don't know why is it low. Please, am I audible? Right, clearly. Alternate manner matrix traversal. Yeah, we can have it. Right. I guess we haven't covered it. So yeah. Okay, so spiral traversing a matrix, right? Let's go with the problem description together, right, guys? See, given a matrix of size R cross C, where R is the number of rows and C is the columns, traverse matrix in spiral form, right? Now there is something new in this problem. Uh, there is something new in this problem, that is expected time complexity and expected space, auxiliary space, right? So far we have like heard of these terms, but we don't actually know the meaning, right? I guess others has started time complexity, so you guys know what is R and C. Voice breaking. I have a good internet connection here. Okay, just give me a sec, guys. Just give me a sec.
No, it's clear, sir.
Acha, okay, so audio is correct, right? So it might be a personal problem, right? Guys, please like try and like figure it out. Okay. Right, please try to rejoin this class if you are very busy. Because most are. Okay, so let's have a look at the input, right? The first line contains two integers, R and C, right? As I said, R is the number of rows and C is the number of columns. The next R lines contain C space separated integers that are elements of the matrix. Simple. Okay. Not explained yet. See, it's basically R cross C is same as N cross N, right? N cross N or N square that we have talked about several times. See, right? R cross C is basically just giving them specific notations, right? Rather than talking in general with N, now they're talking about rows and columns. Okay. So I guess input is pretty clear. It's standard input of M cross N matrix, right? Yes, Harsh is right. Okay, so let's have a look at with the initial steps, that is creating a scanner. Right, let's create the scanner as usual, that is new. System dot, right? So what do I need to take as the input? I need first R, right? Sc dot next int, right? I took the input of rows int. Let's create C, that is sc dot next int, right? Now I have both the rows and columns. Wherein we will be having a look at spiral traverses, I'm just like setting up the code for the inputs. Okay. Now, what is the next part? We need a 2D matrix, right? To basically take the inputs, right? So let's create a matrix that is a 2D matrix. New int. What should be its dimension, right? It should be R cross N. So first is the number of rows and second is number of columns, right? So this gave me a R cross C matrix, right? Now we need to take the inputs. So for int I is equals to 0, I is less than R, I plus plus, right? Basically traversing at each row. Now for int j is equals to 0, j is less than C, right? J is basically traversing in columns. So j plus plus. Okay. What do we need to do is we need matrix at I comma j, right, is equals to sc dot next int, right? So this is the part of taking inputs, right? Now the next major part is what is spiral traversal, right? So let's quickly jump to the notepad and let's try and understand what is this spiral traversal mean. Okay. Okay, I hope the notepad is visible, right? So let's have a look. What does this spiral traversal mean, right? So okay, let's create a 2D array, a simple one, right? So 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So if we talk about the normal printing using the for loops, right? As we do, I is less than n, or nested inside we have j is less than n. So in that case, if we talk about the printing, how does the print happens? See, the print happens in such a format key basically it first completes the first row, then it completes the second row, then it completes the third row. Am I right? So we get a output such as 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now this is the normal one, right? This is the normal traversal. When I talk about spiral traversal means basically moving in the matrix in a spiral format. What does that mean? We start from the top left element, right? This one, that is 0, 0. We start a spiral traversal. We first go towards right most element, or you can say column. We go with the printing of 1, 2, and 3. Now, instead of starting from the 4, right, element 0 or 1, 0, we continue the printing in a spiral format, right? So we now go towards down direction. That gives us a printing of 6 and 9. See guys, 3 is not repeated, right? It's only printed 1. You can see if we go from 1, 2, 3, 6, and 9. So it's a continuation in a spiral form. Now you guys might have already this like estimator like guessed key. The next is in this direction, right? So that gives us 8 and 7. Okay, so you can see again a 9 is not repeated because 9 is a part of the previous traversal, that is this. You can see it's a intersection between these two lines, so we have to like figure out a way in which we are only printing it once. Okay, again now let's continue the pattern now upward direction, right? So this time we need not to go till 1, right? Because 1 is already printed. So we got a new print of 4, and again we continue the pattern, right? So we go inside. So this gives us, okay, you can see we are printing elements only one. If any of the element is already printed, we are not like printing it again. Okay, so this is how the spiral traversal is, right? Spiral. Okay, you can see it's something like this spiral, right? That's why it's called spiral. Okay, now let's try and figure out key how can we like reach a solution, right? We have seen the inputs, right? Now let's try and build an algorithm. Okay, so this problem is pretty huge. It has like several steps to basically figure out the solution. So let's have a look at them by one. Okay, now if I talk about the spiral matrix, see, let's keep the same spiral matrix again, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now, before moving further, any doubts in spiral traversal? What is exactly the spiral traversal? Any doubts? No. Okay. See, one thing to observe is key when we talk about a spiral, right? You can see in the pictorial representation itself, I have an outer bigger loop, right? Outer bigger loop is of this size, right? Outer bigger loop is of this size, right? Now, after so what's the agenda of today's doubts? See, Harsh, today's doubt session is about completing the assignment, that is 2D array. Okay. See, if I have a look at the spiral terms, okay, the spiral, someone is asking about anti-clockwise. No, as per the definition of the problem, spiral traversal is in the clockwise manner, right? So towards right. So that's why we are getting this kind of spiral. Now, I can say key if I draw a starting point like this, right? So this is the starting and ending point. Outer loop was a bigger loop. Let's talk about internal loop. Internal loop is small, right? Again, if I talk about one more loop inside it, so you can see again the internal loop will be much small, right? So from this, I can basically analyze key. Okay, if I talk about in the spiral in terms of a box, right? You can see we are somehow creating a box-like structure, right? If I continue it, I will be getting at this, and this kind of structure, right? So you can see it's something about boxes. So for a box, I can say I have four boundaries, right? That is the top boundary, bottom, right? That is right, and that is left. Agreed? So each box has four boundaries in which the loop is concise, right? Okay. So we got to know ki we let's also note down these points, right? The first point that we figured out is ki we have four boundaries, right? Four boundaries. Now, what are these four boundaries? We figured them out. That is top, right, bottom, left, and right. Okay. Any doubts in this boundary part? What I'm talking about boundary? What do I mean by boundary? Right? Because we will be building this solution on in a layer wise. Then we consume that. Consume that. I'm not sure about what do you mean by consume, right? We basically use these boundaries to limit our operation, right? See, it's not a simple like a situation in which you can write key for loop from 0 to n less than n, right? Because you can see every time the length of that for loop will have a different starting and an ending point. So that's why we have to talk about the boundaries. Okay, so from which boundary do we need to start a traversal and to which boundary we need to end, right? So let's say what I'm saying is ki basically see, if this is the box, if this is the nth boundary, right, nth box, if I need to basically print from left to right direction, what do I mean by left to right direction? You can see this arrow. See, left to right direction, if I need to print, I need to basically know, okay, so what was the last print? After that, what is my current boundary? So my new printing will start from the start of that boundary part, right? Which is the start part, this part. This is my start part. Now the for loop should move till this end. It should not pass, right? Because I might have an element, right? Let's say X, Y. These elements are still there. But from the above pictorial representation, I can say that these were already, these might be already be covered in the outer boxes, right? So we are like concising our answer to the inner core, right? You can see the box gets smaller and smaller. This helps us to basically prevent the reprinting of the elements. Got it? Why we need boxes? See, what I'm saying is, see this. This might be another box. Yes, boundary will be updated after every completion of a direction. Right? See, these might be the boxes. So you can see Y is already covered. Inside that we have an inner box that covers X. Inside that we have a new box in which currently we are working, the white box. But for working in the white box, I need these four boundaries to basically figure out, okay, so now I need to start my printing from this end till this end, right? After that, from this end till bottom, from bottom to right, sorry, left, and from left to top. Okay. There is a special case key. We don't go from this. You can see we have a buffer zone, right? So this basically goes till the next boundary top only. Okay. Jyoti, I already shared, right, the link. Please have a look at the WhatsApp group that we have. You might be finding, or someone can share it. Maybe. Okay. So I hope the boxes concept is clear, right? Why do we need boxes? Okay. Apart from boxes, what is the next major thing that we can see, right? Apart from boundaries, I can say we need a direction in which direction we are currently moving. You can see I have arrows, several arrows, 4 arrows, right? So again, how many directions do we need? Let's again write it down. Anybody can make a guess. How many directions do we need? 4 directions. Right? 4. Right. Again, what are these 4 directions? I can basically say ki from top we can go towards the bottom, right? What is this? This is this one, right? Let me also draw a small like representation. This one, right? Top to bottom. Okay. Now let's also figure out what are the rest. From top to bottom, apart from this, we can have left to right. Right. We can have left to right, right, bottom to top, and from right to left. Got it? These are the 4 directions. From left to right basically means ki left to right, bottom to top, and right to left. Okay. Now, 4 boundaries, 4 directions, right? So we have these boundaries as a flexible values. These directions will be changing one by one, right? We will be having a look how. See, I can say there is a set pattern in changes of direction, right? You can see first, the by default the direction will be left to right, right? You can see. Let's do this, right? So let's talk about this matrix only. The first direction that we need to work upon is left to right. Why left to right? See, because it's a spiral, right? So how does a spiral start? It goes in a clockwise direction, right? So for going into clockwise direction, I need to move from left to right. So that's why it is going to left to right first. Okay. Also, the program by default asks us to print the entire matrix. So if we need to complete the entire matrix, we need to start from this element, right? It's given. It's a given condition, right? It's a given condition. So that's why we need to do. Okay, good. Now, if there was something specific said to us, you need to basically print from 3, right? In that case, what will be the starting direction? I can say this will be the starting direction, right? Because I can't go any further, right? So as per the problem, we need to start from this part, right? We need to start from this part. How do I know that? You guys might be saying, sir, there is no line specifying this. If you clearly have a look at the example outputs, you can see the example output starts the printing from the very first element, right? As you have done above. It doesn't start from the any element that is in between the spiral poles. Okay. Now we figured out key. So first we start from the 0, 0 element. First direction that we need to move upon is left to right. Okay. Now, if we are moving from left to right, which row we are using, which row we are utilizing, right? See, now there are 2 points in this. One is direction and one is the row that we are like currently consuming. Okay. These are 2 separate things, but they are working together. Left to right, right? Let me say left to right. But if we are moving from left to right, you can see, you guys are saying 0. You are correct, but you are correct for a specific case. Let's talk in a general terms, right? I can say I have given names to my boundaries, right? So this is the top boundary. So whenever I move from left to right, I'm consuming the topmost row, right? I can say I'm working upon the topmost row. Am I correct? Right? See, now the second direction that we need to work upon is from is this one, right? It's the B. So second direction is this one. Which direction is this? It's basically top to bottom, right? When I'm moving from top to bottom, which like row column I'm consuming? I can say this time I'm consuming the rightmost column, right? Last. You can say last, start, end, rightmost. So let's write a last, right? Because we already using R for right. So let's say the last one, right? So last. Okay. Now, similarly, continuing the pattern, we can say next direction is this one. What is this? It's basically from right to left. This time we are working on the bottom part, right? Bottom part. Again, the last direction, right? The last direction. That is bottom to top. Which part we are consuming this time? Anyone in the chart? Yes. If this was last, this can be the first one, right? So let's say the first. Okay. So I hope 3 concepts are clear now, right? These 3 pairs, boundaries, right? Why we need boundaries, how spiral traversal works for boundaries. Apart from that, the directions, and when we are working in that direction, which basically boundary we are consuming. Okay. So 4 boundaries, 4 combinations, right? So please have a look at it. Okay. Now let's try to start to code it, right? Let's try to start coding. Now, if I basically do this thing, let's say I create a variable called direction, right? Let's say I create a int direction. It's denoted by D. I can basically give a numeric values to these 4 directions. These are fixed. They are just telling me, okay, so you need to move in this direction, right? So let's say ki I basically give a direction to a name to this direction, right? Let's basically keep it in clockwise direction. So let's start from what is the first direction we are moving from left to right. So let's make it 0. Cool. Let's make it 0. So left to right is basically denoted by 0. Let's also write it. Let's basically use a different color. Pink. Okay. So this direction I'm denoting by 0. Okay. You can see 0. What is the next direction? After left to right, I'm going from top to bottom, right? So let's basically mark it as 1, right? This direction I'm denoting with the value 1. Okay. Next is right to left. Let's make it 3. 2. 0 base काम कर रहे हैं 2. So let's say 2. Last is 3. So this is now. If these are the numeric values that are representing key, okay, so please go in this direction, please go in this direction. What will be the starting value of D? Anyone? If I'm declaring a variable that is helping me decide in which direction I need to move, what will be the starting value of D? Okay, I got 3 answers. Anybody else? I'm just asking about the direction. So yes, you guys are right. Harsh, you are wrong. You said 1, right? So the starting direction value will be 0, right? Because you can see left से right सबसे पहले जाना है, right? हमें so left से right पहले जाना है, तो हम इसको 0 रखेंगे, right? What is D actually telling us? D is actually telling us कि okay, this time you need to move in this direction, right? It's not telling us about the previous one, right? Dharmendra, you said key 2. I basically assume you are basically telling us okay, what was history? What do we need to do now? Yeah, it's basically you can think of it in any like way you need to utilize, but as per current scenario, we will be like sticking to the direction which we need to currently move on, right? We are not looking at the history. We are like checking ki, okay, now ab kya karna hai, right? What do I need to do now? Okay. Yes, see, position doesn't matter, right? Position आप 0 0 नहीं बोल सकते. मैंने आपको क्या बोला कि this time we are not like doing a simple printing in which ki there is a fixed set ki every time like printing starts from the 0th element. No, this time boundary changes, right? You are going to the core element, right? You are like going inner and inner and inner, right? So that's why we are this time we are like generally talking in general, right? We are not using any fixed values. Okay. So yes, things are clear, right? Now, don't you guys think कि this is a like a fixed pattern कि एक के बाद एक के बाद एक के बाद एक direction में जाना, right? And when we are like done with the traversal of one direction, I can basically say कि okay, the top element, top row is done now, right? So please reduce this boundary. What I'm saying is, see, let's say this is the values. Okay, these are the values 1, 2, 3. Let's make it a bigger one, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. See, this time how basically the direction boundaries are moving. Okay. Initial values, let's also like basically define the initial values of these boundaries. Okay. So I can say key initial values of the top, right, the bottom, the left, and the right. We are given that this is a R cross a C matrix, right? So it's a R cross C matrix. So can you guys help me decide what is the value of the top? What do I mean by top? Is this one. What is this boundary doing? So I can say this is my top boundary. What can be the top boundary be? I can say it basically it makes sense to basically start it with 0, right? Because the 0th row is my topmost boundary that I need to still work on. Okay. Similarly, in the case of bottom, I can say this one is my bottom boundary. Right? What will be the value of bottom? I can say it will be R minus 1. Again, see, guys, please don't like do work in number, right? And if you are working in numbers, you are basically still being rigid to the fixed values. Don't be fixed. Make it as flexible as you can, right? Answer means flexible. So let's say ki it's smaller. So R minus 1, right? Now, similarly, I can say what is left going to be this one, this part. Let me just use another color. Okay, yellow. This part. This is the left part. What will left be? Yes, 0. Right. And what will R be? C minus 1. Yes. Okay. Someone asked why R minus 1. See, these are the rows, right? 1, 2, 3, 4. So how many rows do we have? 4. But when we talk about it in the zero-based indexing, I can say there are 4 rows. So the index of the last row will be R minus 1. That is 3, right? So that's why minus 1 is half. Cool. Now, see what happens. Initially, let's start to basically do a dummy traversal, right? So let's say, okay, we know the values now. Let's also have a direction value, right? We figured out, okay, initially the D should be 0, right? What was 0 representing? Let's also create a mapping for it, right? Let's create a square, 4 direction cross, right? So this was the 0, this was 1, this was 2, and this was 3. Agreed? This is my compass, right, for this problem. Now, let's start to traverse. Starting from this, direction is 0, right? Guys, direction is 0. So what does that mean? Please move from the left boundary to the right boundary. What is right? This is right. Please move from the current left boundary to the right boundary using the topmost, right? We figured it out. From left to right using the topmost. So let's also write the output, right? Output is going to be 1, right? 1, 2, 3, 4. 1, 2, 3, and 4. So I did this traversal. Now you can see I have used the top row. So does this make any sense to have that boundary as of now? I can say when I am done with any row, I can shrink it, right? You can see if I draw a traversal, it's like this, right? It's like this. This is the spiral. So rather than still keeping this boundary, I have used it, right? So why don't I use it for my benefit? I simply do this. This is going to be the new top, right? This is going to be the new top. What is going to be the new top? This one, right? This one is going to be the new top. R minus 1, C minus 1, right? Okay, Mehran, please be with us. I will be explaining R minus 1, C minus 1 in a moment, right? Okay. Okay, guys, you understood why we reduce it? See, it helps me in 2 ways. How? See, now after this, okay, let's basically continue the steps that we require. So I printed the values. I shrinked the boundary. Now I need to also change the direction to basically check. Okay, so I'm done with this direction. Please keep a record. Next direction I need to do is this one. So what will be the new value of D? What will be the new value of D, everyone? D is basically direction. Yes, you guys are correct. See, we are done with the 0, so I need to update it to basically 1. So D becomes 1. Cool. Now, if D is 1, boundary is reduced. Now, what was the second step that we need to do? See, now we decided, okay, start from the top boundary, go till the bottom boundary using the last column. What is the current top boundary element now that we are standing on, right? If I keep a record of the printing also, this is what we are done with, right? For 4, we are done. So what is the current element that my pointer should stand at, right? You guys are right. The top is this, but if I'm talking about the last column, it's going to be 8, right? So did you guys notice one very important thing? I said we should not print the corner values, right? You can see 4 is the part of top as well as the right. So if I reduce the boundary as soon as I have printed it, I'm basically preventing that element to basically be a part of the next printing only, right? Because this time I'm not considering 4 to still be my top. I'm done with that, right? I'm now considering 8 to be my top. Did you guys understood this? Okay, so if in that case, let's just continue with the printing part, right? Let's continue with it. So 8, 12, and 16. 8, 12, and 16. Okay, now what is the next step? I need to basically reduce this boundary. Okay, so I need to basically reduce this boundary. Let's keep this. So now this is going to be my right boundary. Cool. Now, what is the next step? Right, I basically reduce. Yes, C minus 2 नहीं होगा, C minus minus हो जाएगा, right? उसको हम ऐसे लिख सकते हैं. What was my current C? We can do that with a minus, right? So basically decrease it by 1, right? Okay. Now you can see what should be the next step. We are done with this. Next step is basically change the direction, right? From 2 we need to go to, from 1 we need to go to 2. So now the new direction will be 2, right? So what is the next thing we need to do? Now we need to go from right to left using the bottom boundary, right? Am I right? Right to left using the bottom. You can see it's marked with 2. Basically direction 2 is telling me you can do this operation. Okay, so now let's do this also, right? Basically start from 15. You can see again 16 is prevented from being printed, right? Because 16 is now not no more the part of current box. See, you can see as soon as I am done with printing, I reduce that direction. See, so I shrink the boundary, helping me prevent this 4 to be reprinted. Similarly, I did this. See, I printed this 8 to 16. That was the left part from the right side. I printed it, I shrinked it. So that basically helped me prevent the overprinting of 16, right? So now what is my rightmost boundary? This one. The 15 I can say is the rightmost at my rightmost boundary. From 15, I need to go to the leftmost boundary. So 15 is a part, 14 and 13 is still the leftmost boundary. So let's do this. These 13, 16 ke baad, let's print 15, 14 and 13. Again, once you are done with the printing, please shift the boundary. Okay, so let's shift the boundary. Right, so this is the new boundary. That is the bottom part. See, if I keep a track of red part also, that is the current printing that we did. You can see, I'm not like overdrawing the red part, right? I'm simply doing कि red कहाँ से कहाँ तक चला था, right? It started from 8 and it went till 16. It started from 15 and went till 30, right? And initially it started from 1 and went till 4. Okay, so this is how we are like preventing the overlappings using our algorithm. Okay, now next is direction. You guys already answered कि r minus minus नहीं होगा, इसका हम b plus plus करेंगे, right? Because see, we are not consuming the right part, we are consuming the bottom part. See, रेड लाइन कहाँ ड्रॉ हो रही है, ये कंफ्यूजिंग हो जाएगा थोड़ा सा. जैसे आप मतलब इसको देखोगे ना कि we are moving in directions, we are consuming the rows and columns, right? And then we have to shift the columns and rows, right? Please make sure कि I have decided कि okay, so this is the decided part. This is the directions we need to follow. How I'm doing it? I'm using it using D. But the actual consumption of the printing is happening upon the rows and columns. That is this red part. See, right? This is exactly what I discussed in this diagram. Got it? So rather than doing R minus minus, we will be doing a B minus. Got it? B shift हुआ, R नहीं shift हुआ. R ने तो printing में help करी, ये boundary की specify करके, right? So you can also generalize it कि if we are like moving in horizontal direction, we are consuming the vertical boundaries. Okay, right? We are like, if we are moving from the vertical boundary to vertical boundary, we are consuming the horizontal part. And if we are like moving from horizontal to horizontal, we are consuming the vertical part. Yes, this is the part where it starts to get a bit tricky. Okay, अभी तक समझ आया होगा, अब थोड़ा सा ना ट्रिकी होना शुरू हो जाएगा. बस इतना सा ही ट्रिक है. एक ये डायग्राम कि देखो, see, if I'm moving from the left to right, I'm basically consuming the top row. See, this is the exact gist of this problem that is the most confusing. Okay, if I'm moving from the top to bottom, I'm working on the last column. Got it? If I'm like moving from the right to left, I'm using the bottom row. And similarly, bottom to top, if I'm moving, I'm using the first row. This is the set rule of spiral traversal. Right? Just keep this in mind, right? Just keep this in mind, or let me just keep it with me. So, okay, so let's keep it with ourselves also. Yes. right? So this part will help us keep what is happening. Okay. Now we move from right to left. See, right to left boundary using the bottom row. Using the bottom row. So now if I'm consumed with the bottom row, I need to move the bottom boundary. Okay. Left and right are just the boundaries in which I need to print, but the consumption happened in the bottom part. So bottom is now used. Left and right are not moved. Okay. Let's continue the operations further, right? So this time I need to go from what? See, 2 wala part is done. Now after 2, I need to go till 3. So direction becomes 2 to 3. Direction become 3. Agreed? Direction became 3. Okay. So if direction became 3, what should happen? कि direction 3 के लिए हमने top bottom to top जाना. Bottom boundary क्या है? ये वाली bottom boundary. Right? और top boundary क्या है? Top को अगर extend करें तो top ये है. तो printing should happen in from bottom to top. Right, printing should happen from bottom to top. It should not go all the way to 1 because that is not a part of the top boundary as of now, right? We shrinked it in the previous operation, right? So this is helping me twice. It prevents the over operation on the 4 that was a part of 2 sides. It also helps me to keep a track कि मेरे को याद नहीं रखना पड़ेगा कि पिछला बॉक्स कितना बड़ा था, अब एक छोटा करना नहीं. जैसे ही काम हो गया मैंने उसको छोटा कर दिया, तो इससे क्या होगा कि अगली बार जब मेरे को बाउंड्री पे काम करना पड़ेगा ना, वो बाउंड्री पहले से ही छोटी हो रखी है, राइट? उसका कोई सेंस नहीं था कि मैं उसको बड़ा रखूं, तो मैंने उसको पहले ऑपरेशन कर दिया, उससे कारण मेरे को बाद में कैलकुलेशन में कमी है. ठीक है. सो ऑलरेडी इट वाज टेलिंग मी ओके, सो नाउ द टॉप. ओके, सी व्हाट आई सेड इज कि like shrinking as soon as I am done with the consumption of that part helped me to prevent firstly the over operations on the 4, that is twice printing, first from left to right and then top to bottom. Agreed. The second is ki as soon as I shrinked it, I basically helped my code remember ki okay, I'm done with the first row, no need to go till 1 now, right? Your new boundary is till 5 only. Okay, so this is why it's helping me to this. Now if we do this printing, what should be the new prints? It should be 9 and 5. Okay, so 9 and 5. I don't have space like here, so I'm basically continuing it. Right now 9 and 5 are printed. See, please guys tell me which boundary should I like shrink now. I did the printing of 9 and 5, basically going from bottom to top. What is the row or column that needs to be shifted now? Please tell me in the chat, or you can unmute yourself if you want to have a conversation and have a doubt. Anyone who knows what boundary should be shrinked now? You can like use this. Yes, Sunny answered. Okay, Kunal answered. What about the rest of you guys? I can see several participants present. See, I'm not like telling you guys to answer me the correct one, right? Answer what you understood so that I can know कि okay, ये जगह पे बच्चे समझ नहीं पा रहे, right? So please answer what you understood, right? I don't want a right or wrong answer. Okay, rather than writing the R1, R0, please tell me L, B, T, and R, right? So I have named these boundaries: L, top, row, B, right? So which boundary should be shrinked now? Okay. Yes. So we move from bottom to top and we consume the left part, right? You can see the first column. So I can see the left boundary should now shrink. Okay. So if I shrink the left boundary now, right, because we are done with the printing of 5 and 9, right? So it should shrink the first column, right? We marked that with the full L boundary. The new L boundary is this. Okay. Now you can see what happened is ideally the outer for loop was this, or the outer box was this. Okay, let's just draw it with white. See, initially when we started the operation, this was the box that we were working upon, right? Agreed. As I said, now the box shrinks. What happened is now the new box that we need to work upon is shrink. This is the new box. Agreed? So 6, 7, 10, 11, right? These are the new elements that we are going to consider as our matrix. Okay. See, the outer box was bigger. We shrinked it. So you can see this is what is happening. Let's have a look at the spiral part also. We shrinked in this manner, the first top, right, bottom, and then left. We did a printing. But after this, you can see we shrink. We are now supposed to do the same operation in a smaller area, right? Also, I represented it with this part, right? See, we are done with the y part. Now the next part is x. What will help us decide x? This new boundaries. Okay, so this is the reason why we talked about the boundaries, directions, right, and how to handle these traverses. Okay. Sanket is asking how shrinking is done. See, shrinking is done as soon as you consume one direction or basically one row or column. What does consumption means? You are done with its printing, right? You have traversed on it. Now I need to basically reduce that part, right? When I move from, let's say, see this one. When I moved from left to right, so I know ki I will be working on the top boundary, right? Left से right तभी जाओगे जब top boundary, right? So you will be moving after this from top to bottom, right? So top to bottom will be worked on the column part. Which column? Last column, right? बीच में किसी column पे नहीं जाओगे, right? You might be in the middle of the column, right? Let's say कि you are in this case, great. You are in this case working upon 7 and 11, but are you working on the middle column or the last column of the new boundaries? That's why I basically asked you guys to keep it as general as possible, right? You guys were answering me in the numbers. See, this is what happens when you write an algorithm. You don't write it with the one case. You basically generalize it. Okay, we will be using variables. We will be using flexible names. Okay. So what I mean by the last boundary is the current boundaries. What are they? Right. Okay. So one thing I forgot is to basically update TBR, these values. See, initially top was 0. So now top became, okay, top became 1. Right. R was -1. So B became R -2. Right. So L became 1 and R became C -1. Oh, C -2. Sorry. See, so these are the new boundaries. Okay, after one iteration, basically I just forgot, sorry guys, to basically update it in the real time. Right? So when we were shrinking the boundaries in the pictorial manner, right, shrinking this, that basically meant ki okay, T ko 1 bana, right? Okay, now these are the new boundaries, and I can say ki it's basically simple repetition of the things that we did for the larger part, right? There is no new thing that we need to consider. If we talk about the question in the terms of boundaries, the exact same operation is to be performed. Okay, but with respect to new boundaries. Okay, so that's why we were talking it in the terms of L, T, B, and right. So is this thing understood now? Any doubts still we have, please let me know. Only then we will be working with the 6, 7, 10, 11 part.
Sir,
Yes.
so how can the 5 will be exempt after the first box?
Sorry, you are asking how can we make sure that 5 is exempt out of the box?
After the first box move.
See, what happened is ki basically when we use one element, right, we shrink that part of the boundary. See, what was this previous boundary? This was the previous boundary, right? But as soon as we did the printing of 9 and 11, 9 and 5, we moved this boundary. Okay, so we moved the L boundary from this to this. So this is the now new boundary. Whatever is outside of this boundary basically doesn't exist for us, right? So we will not be considering it in our current solution. Now, how will we do that? See, basically, this is one more thing that I need to show you guys, right? Just be with me, right? So see, how will we do printing, right? So far, we have talked about directions, boundary, shrinking, and so valid question that you asked is ki how I make sure the 5 is exempt. When I will be writing the print algorithm, right? What we generally do in the normal part is, see, I'm writing normal, right? And in this problem, see, in normally we write a for loop for int. We know the starting part, that is I is equals to 0, I is less than n, that I'm considering n to be the number of elements, right? I plus plus, and let's say we are just talking in one direction. So let's basically do a printing of print, right? Print something ARR at, right? What does this means? I am just considering this 13, 14, 15, 16 to be a single row. And now I'm like printing from 13 to 16, right? Normal printing, how it's done, right? Now, if I talk about printing, how will we do it in this problem? We won't be using any solid values, that is constant values. We will be doing for int I is equals to boundary name, whichever direction we are moving, right? Why? That's why we have a pair of boundaries, right? L to R, B to T, R to L, right? So we will be starting from one boundary. Let's take the left to right wala. So I will be starting. Okay, so start from the left boundary, go till I is less than the right boundary, and please increment it by 1. Okay, slow. Okay, see, this is how we will be doing the printing in this value. You can see I'm not using any solid value, that is 0, n. I'm not using those. I'm using my boundaries that I created, right? So L, R, you can see this L, this R. So this is why I can make sure the next time when the printing starts, the print won't start from 5. The print will start from the current boundary that I have, that is 6. So that makes sure 5 is exempt of the new print. Okay. This is the main difference. How will we do the printing part? Okay. Any doubts? Now, please let me know any doubts you have. Right. Please unmute yourself, like as the guy asked, what is your doubt? Please tell me your exact doubt so that I can like directly address. Okay. Yes, anyone who is having confusion, any doubt? Yes, first is top boundary from left to right, right? Working on the top boundary, moving in left to right direction. This diagram, please keep this diagram in mind, right? This diagram. Okay. If I zoom in, this is the part. Left to right, working on top, top to bottom, working on last. Okay. Okay. So if nobody has any doubts, let's keep the flow. Okay. So far what we discussed is we need 4 boundaries, 4 directions. We found an algorithm when we are moving in one direction, which boundary we are consuming. After we consume that boundary, we need to shrink it. Okay. Now, let's also talk about the printing part. We decided, okay, so printing can be done using this part, right? This is normal printing in which we fix the starting value. But in our algorithm, we are working on boundaries, right? So we will be writing the for loop in a flexible manner that is able to like optimize itself to basically new boundaries. How can I do that? L to R, T to B, B to R, right? Any combination of these 4 values, right? These are the 4 valid combinations in the direction that we need to print it, right? Okay. So let's do this also. Now, how do I figure out key? Okay, I had a direction in my hand, right? We are always talking about direction B, D is equals to 0, 1 or something. But how do I know key? Okay, so how is this actually helping me? I can basically use a while condition, right? While condition. See, just listen to this while condition for now. I will be explaining it in a bit, right? So I can write while top is less than bottom, right? Top is less than or equal to bottom. And left is less than or equal to right. Okay. Now, what does this statement mean? So it is basically telling me to do an operation till top is less than or equal to bottom boundary and left is less than or equal to right boundary. See, do this operation until there is a space between the top and the bottom, or there is a space between, and there is a space between left and right. So what does this spacing wala part means? Please make sure there are some elements in between to basically print. What will happen in the stopping case? See, in stopping case, the left boundary and the right boundary will overlap. So that basically means there is no element between left and right boundary. Okay, there is no element between left and right boundary. Now, also there is a case ki, see this can happen ki top and left boundaries are still present, right? There is some element between top and left boundary, but you can see we are already done with all the left half, right? All the left half and the right half of the array is printed. So there is no new element in between this section to be printed. So that's why this condition comes out. Okay, this condition comes out. Still, if you guys are facing any doubts, let me just generalize it by telling you guys in this part. See, now this is an even matrix. This is an odd matrix. What will be the last elements in the bigger area? Let's talk about the 4x4 wali matrix. What will be the last element to be printed? What will be the last element to be printed? If I continue with the process, right, we are done with till this one, right? 6 and 7 will be the next print, 11 will be the next print. After 11, we will be having a 10. Do I have anything to go up? Do I have anything to go up? No, because in this part, as soon as I am done with 6 and 7 wala part, what will happen is ki the top boundary will shrink again. What will be the new top boundary be? This is going to be my new top boundary. Agree? This is going to be my new top boundary. After I'm done with the 6 and 7. Now, after this, I will be printing out 11. If I print out 11, right part will see the closest boundary to this basically moves. So this will be my new boundary. This is R. Still, we are in the loop. We haven't like completed 4 directions. What is the next part? R say L job, right? Go from R to L, basically print out 10. If I print out 10, what will happen is the bottom boundary will shrink. Agreed? Whenever I'm going from right to left, you can see yellow wala part. When I'm going from right to left, bottom boundary is being shrink. Okay. So if bottom will shrink on the printing of 10, what will happen is, see, this will be my new bottom boundary. This is going to be my new bottom boundary. You can see there is still a gap between L and R, right? That is telling me, okay, see 10 and 6 are in between these boundaries. But are those elements to be printed? I can say no, because this thing is telling me that there is no element in between, right? There is no element in between. Okay, so basically don't do a printing of this. Okay, don't do a printing of this. Got it? So basically, okay, you guys might be thinking ki, sir, you have written an equality case also. See, it's how it is going to happen is T will be considered this one and B will be considered this one, right? Why so? Because see, when we are like trying to do, when we wrote 1, 2, and 3, 4, and 5, and 6, I basically did this as a top and this as a bottom. Okay. Ideally, what should happen is I should write this as a bottom. I just did that to basically help you guys to understand. Now, if this is the boundaries that I need to talk, okay, if I'm talking about ki, okay, जो bar जिसके ऊपर है वो वाली consider हो रही है, right? So I guess this might be now starting to get confusing, right? So this is the just 2 things that are confusing in this one: the while loop and the boundary and direction, right? So just to keep it in easy terms, if the boundary overlaps, right, overlaps or crosses each other, right? If top is supposed to be before bottom, right? Top should be smaller than bottom. Only then I have any element in between. If that condition contradicts, right? Bottom is now above top. So is there any point that there will be any element in between this? I can say no. That basically means that all the upper half of the matrix and all the lower half of the matrix is printed, right? So this was the case of even matrix. What happens in the odd matrix? What will be the last element to be printed in this one, the smaller matrix? 5. Yes, 5 will be the last element. But for 5, I can say the boundary will be this, right? This is the boundary before the start of operation of printing, right? This is going to be boundary. But as soon as the boundary happens, you can see the top boundary will shrink. Let me just, right, this will be the boundary. What happens is कि पहले left से right जाएंगे. When we go from left to right, the boundary of top shrinks, right? So this will become the new boundary, right? So you can see now still there is an element between left and right, but boundary of top has crossed the bottom boundary. This invalidates the thing, right? It invalidates. So that's why I can say that there is no element in between this, because see, even though I have the left and right boundaries, the operations are supposed to be performed on the rows and columns combination, right? Direction is also important. The consumption of row and column is also important. Okay. So that's why we have this rule. Okay. Please guys, I request कि इसको वीडियो को दोबारा देखना एक बार, तब समझ आएगा अच्छे से, राइट? बिल्डअप करके स्किप कर करके एक एक पोजीशन पे देखना क्या चीज कही गई थी, राइट? नाउ इन दिस व्हाइल लूप I got to know कि okay, so I need to perform my execution till this part, till this condition holds. Apart from this, what do I need to do? Now I need to decide कि okay, while loop तो चल रहा है, but what to do in this while loop? I can have an if else part. If d is equal to 0, if d is equal to 0, now this direction, this is working on direction, right? We had a mapping. 0 means ki left to right. 0 means left to right. Okay. In this, we need to do some sort of an operation. Now, what do we need to do an operation on? We need to write a for loop for int, right? Left to right. So let's talk when we go in left to right, we basically use j, right? So let's talk about j. What should be the starting value of j? Anyone? What should I write j equal to? I guess I told you this, right? This time we need to keep it as flexible as possible, right? We can't write 0, right? We need to write, we start from the left boundary, right? The biggest hint you have is write this, in which direction we are currently moving in. So left se shuru karna, go till j is less than, right? This one, less than or equal to, right? Because less than and equal to. Now what should j be less than and equal to? Yes, r. Should j increase or should j decrease? Should I write j plus plus or j minus minus? Yes, exactly, j plus plus. Plus plus. Now, if I'm writing this condition, I can say ki print. Wait, I'm not writing system.out. I am just writing a pseudocode of print. Okay. If this is the thing, do a print of matrix. Let's call the 2D matrix a matrix. Okay. Okay. Please help me decide these two values. If you guys are able to decide these values, trust me, you understood the problem. Okay. What should be the first and the second parameter in this? Okay. What should be? Okay. I will be giving you a hint. Whenever like we are going from left to right, we are working on the top. Right, we are working on the top. Yes, yes, you are correct. We will be using the top row and using the jth column, right? Why jth column? See, 1, 2, 3, 4, 5, and 6, right? This for loop is going to print in this direction, right? In this direction, it's going to print. So j will move like this, right? But the t that is top row stays the same. So that's why we have like top with j combination, right? We have a top with j combination. Got it? Any doubts in this part now? Because this is the most crucial thing after those directions, right? How do I use them? We built a concept, we built an algorithm, but how do we actually use it? This is how we actually use it, right? You can see I'm utilizing the direction, telling me which direction do I need to move in, using the for loop to basically tell me, okay, so which boundaries in between I need to do a printing. This thing is telling me how do I do a printing, what combinations do I use. The whole story boils down to this part key, basically use the top row when you are moving from left to right. How do we move to left to right? Basically using the second parameter of the 2D array. Okay. Now, after this, the printing is done, right? Do we need to do anything else? Anybody remembers what were the steps now? Printing tak to ho gaya. After this, what do we need to do now? Shrink. Yes, exactly, shrink. How do we shrink? Top plus plus. We can do a top plus plus. Okay, we shrink them. We shrink it. After shrinking, what do we do? Please have a look. After shrinking, what do we do? Anybody remembers? Yes, we can do a D plus. We can do D plus plus, or this thing we can hard code, right? Because if I do a D plus plus, whenever I'm standing at this value, this direction 3, it will make it 4. I can basically do a hard coded value because I know after 0 it needs to go to direction 1, right? I can do a D is equals to 1. This if block is complete. This if block is complete. This will handle the case of printing the top row from left to right. Apart from this, I can have the if else part. Else if D is equals to 1, right? What does D is equals to 1 means? It basically means go from bottom to, from top to bottom. Sorry. Do from top to bottom. Again, I need a for loop, right? We are moving vertically. So let's keep it I this time. Starting value of I, please tell me. T, exactly T. I less than and equal to. I less than and equal to B, correct. I increases or decreases? Increases, yes. I plus plus. Good. Now we need to do a print. Matrix. Tell me the combination. Please tell me the combination of these two values. When we move from top to bottom, right? Top to bottom, we use the last column, right? We use the last column. Yes, I guess you guys might be getting confused. Ki last ko kya bole, right? So why don't we do this thing? Let's denote this first and last with S L end, start and end, right? Rather than using F L, right? Let's call it end, right? The end column. Okay, so I can basically denote it in one variable, that is end. Okay, so this is going to be end column, right? So why don't we write it like this? Key always work on the end column and use the row part, that is I. Okay, so this is going to be the new column. Got it? So E is basically equivalent to last, right? Just to denote it in the code, I am writing like this. Okay, all right. तो ऊपर भी हमने बाउंड्रीज पे काम करा था, राइट? बाउंड्रीज पे हमने काम करा था, तो एल हो सकता है, आर हो सकता है, राइट? तो हम इसको आर भी ले सकते हैं या एंड बोल लो, राइट? बट again, R is using for right direction, so you might be getting confused when you are looking at it. So let's keep it end for this time, right? Just to denote it in the code, we will be fixing it, right? So you guys understood L and R? Yes. Karishma, you are correct. L and R, I and R, anything is correct. Okay. Let's have a look at the next steps. What is the next step? Yes, guys, you just told me the next steps. After printing, what should we do? Shrink. How do we shrink? Which boundary do we shrink? R minus minus. Yes. Right side, we utilized it. We can do a R minus minus, right? R minus minus, or in this case, right? You can also write E minus. Both are correct, right? Because here I'm writing okay, चलो छोड़ो इसको R ही लिख लेते हैं. छोटा R मतलब direction, छोटा R मतलब boundary, ठीक है? Okay. So R minus, right? Let's make it star. Okay. After R, what should I do? Change direction. What will be the new direction be? 2. Correct. Again, end of the if else part. Similar thing, I need to write in else if. Else if D is equals to 2. Okay. If D is equals to 2, simple, do a printing of again. See, D is equals to 2 means move from bottom to top. Bottom से top जाओ, right? we move from left to right, top to bottom, bottom to top is now what we need to do. Okay. Again, we are moving in the row wise, so let's keep it I. Int I is equals to, what should it be? Will be B, right? I is less than equal to, greater than equal to what? Right to left. Acha, हाँ, sorry, yeah, sorry. See, right to left side, right? So this is how it's happening. 0, 1, 2, 1. So right to left, sorry. This is going from right to left, right? So if it like column, so let's keep it J. Let's keep it J, right? So J is equal to, starting from R, right? J is less than or equal to or greater than or equal to, what should it happen? See, now this time we are moving from a higher value to a lower value, right? So it should be greater than or equal to. Okay, so it should be greater than or equal. All right, greater than or equal to L. Again, right? J minus minus. All right. Again, do a print of matrix. Again, combinations without. Right. Okay, so I know it's this time J is moving, so I can write J this time, and we are moving on the bottom column. String. We done with the bottom, so please increment the bottom. Right? Oh, sorry, decrement the bottom. Right, bottom ko upar lana. So bottom minus minus. Direction becomes 3. Got it? Now, since we can also write it in else part. Okay. Right, we can write it in else part. Else, the last direction we need to print is, what is this going to be? It's going to be bottom to top. This time it's going to be bottom to top, right? We are done with this. Now it's this part. Okay, so bottom to top for int I is equals to bottom. I is again greater than or equal to, right? We are moving from a greater value to a smaller value. I is greater than or equal to top, right? Again, I minus minus, right? Print matrix of combination plus some space. Again, now this time we are moving on columns rows. So I will be this one and this will be the left, right? The left one. Got it. Shrink. How do we shrink? L plus plus, right? L goes from this direction. So L plus plus. Apart from this, again, what should be the next direction? You can see we are done using the last. So direction should again start to 0. Should be set to 0, right? 0. Okay. Now this basically ends this if loop and this ends this while loop. Okay. So if else, so this is just while loop using conditional statements and just a bit of analysis and like use of boundaries, directions, using the concept of which boundary consumes which directions. Right. So this is the general approach of how you build this problem. Okay. This is the approach, right? We basically started from the requirements. We found out the requirements, then we analyzed key. Okay, so how do we use them together, right? We decided key, this is the pattern. We used a helper, that is the direction. We tried to do a dry run of the algorithm. We figured out, okay, so what should be the stopping condition? Once we had a stopping conditions, we wrote the code that was general. Right, this time you can see there is no hard coded value so whatsoever in this code, right? It's basically using the dynamic values to basically keep the code as flexible as possible. Okay, see, there is no for loop starting from n-1 or 0 or some sort of, it's spiral traversal. We basically use the what problem asked, move in spiral. We decided how we will be using the spiral movement, and we figured out a way using the helpers, directions, and all this, right? So I hope this algorithm is now clear. The concept of movement is clear, right? See, this is why I didn't took this problem in the last round, because it's a huge explanation to be done, right? The entire class, this time is consumed in this one. but I hope the time was worth it and you guys learned something in this problem. Any doubts in this problem, any part you have, please let me know now. Okay, we have a one request for while condition. Anybody else with any other doubt? Six, 7, 10, 11 confused. 6, 7, 10. Okay, yeah. See,
Oh.
Ishan. Yeah, Kunal.
After the first if condition is a loop continue or else if
Like your voice was humming. Can you just repeat or in chat?
okay.
Confused in printing. Okay, let's tackle them one by one, right? Dharmendra, did you understood the concept of boundaries? What we are doing in this printing part is we are like just we are like setting the boundaries as the limits of the printing. Okay, move from left boundary to the right boundary, move from top boundary to the bottom boundary. That's it. That's basically it for the printing part. Okay, in traversing, no problem. Okay, so what is the error now? If you can just unmute yourself. This code continue in else if part. No, see, Kunal, this is the beauty of if else part. Either of them gets executed, right? It will first check, okay, t is equals to 0, it will execute it. If it's not, it will just cascade it or fall down to basically the second if part. But either of them executes. That's why we are using if else part, right? We are not using if we are not using several ifs. What happens is in several ifs, every if condition is checked, but in if else part, only either of them is executed, right? We can have hundreds of if else, but only one will get executed. Okay, so we can say in single while loop, only one if will be executed. So first for loop explain only printing part. Okay. See, printing this wala part, right? Matrix wala, right? So I hope this part is basically confusing for you. Hey, okay, so you know Naki, in 2D array we like use these two parameters. This one is for row, this one is for column, right? So in the first for loop, we are moving from left to right in the top row. So left to right, you can say we are having a row as fixed. So T row is fixed. T row is fixed, but columns are changing. You can say J is incrementing. So that's why we have a fixed row T, and we are using the loop from that is going from left boundary to the right boundary, working on the several columns. So that's why we are having this as the jth part, right? We are having this as J. Okay. So this is how we are using for loop. Okay. And also we had Ishar 6, 7, 10, 11 is confusing. Okay, Ishar, please do once a dry run on your own, because see, it's basically simple shrinking, right? Please do once a dry run on your, if you still face any doubt, please take. Okay. Okay. Apart from this, someone asked for the while loop wala part, right? So I have a very like a new thing to basically show you guys. See guys, we talked about boxes, right? We talked about boxes. Okay, so you can see this is the box. Okay, or rather, let me just draw each direction, each boundary with a different color. Okay, so see, this is the top boundary blue, red, blue, or rather than blue, let's put different color, yellow, and a white. So you can say that there will be some sort of a shrinking part, right? Whatever is to be done or to be performed on is in between this, right? This green part is the part in which we need to perform. But let's say that there is a situation at the end in which the left boundary and the right boundary passed each other, right? They are now not equal, even though we have a valid condition on equal, right? Let's keep this blue and let's keep this yellow. So you can see this right boundary and this left boundary now swapped each other. So I can say, is there anything in between these things? Right? Is this middle part valid? I can say no, because they only overpassed, right? So this R went in this direction, this L went in this direction. Till this part, they were equal. So that was a valid case. But as soon as they overpassed each other, right? So there is nothing in between this. So this is basically a void, right? Because this is the right boundary and this is the left boundary. Got it? अगर R और L एक दूसरे को पास कर जाएंगे तो वो चेंज हो गए, तो बीच में कुछ नहीं है, right? So there is nothing in between. So that's why we need to stop at that very moment. Okay, because I can say ki all the right part is done, all the left part is done. See, you can see there is no part in between. So that's where we need to stop. Okay, you will be understanding this once you do a dry run on your own, right, guys? See, I can only explain you the concepts, right? But there are some technicalities that you have to sit on your own and figure it out, right? I tried my best कि यही होता है. अगर देखो, if let's say कि we need a single 1D array also, right? This is the 1D array. Okay, let's say कि we have a pointer at I and we have a pointer at J. See, there is only element in between I and J. I'm talking about in between I and J, right? Between I and J. I'm not talking about J and I. Only I and J if I is smaller than J. But as soon as I surpasses J, right? I surpasses J, right? There is no element in between I and J. Between I and J, there is this void part. So this is the exact same thing that is happening in this while loop. Okay. No, this condition will happen in each matrix. So that's why you can see we are using a combination of both, right? You can see we are using a combination of both top and bottom as well as left and right. See, either of them passes, right? Either of them crosses the boundary of their pair. That basically tells you, okay, in the given example, okay, left and right printing is done. So there might be a case, right? There is no set general pattern which can happen, right? Because it's an R cross N matrix. See, there is several. It can be a combination even, odd, even, right? So depending on the situation. Okay, zoom it. Which part? Okay, just let me draw one thing, right? Just let me draw one thing. See this thing. Okay, so sorry. Just let me draw. कि मैं बता रहा था कि हाँ ये top है and the yellow is bottom, right? Even though we can have the left and the right boundaries having some space in between, right? Now this time, see what has happened is okay, let me just take a new color. See the top and the bottom boundary. See, top was blue, bottom was yellow. So now they have surpassed. So what happened in this case is this part, that is top part, and this part, that is the bottom part. They are done with their printing part, right? They are done. So there is nothing in between now to be printed, right? So there can be a combination of both of these cases. So that's why having a space in between the top and bottom and left and right is very necessary, right? So this is why we are having a stopping case. Okay, if this thing is surpassed, there is no element in between. But because we are talking about the elements in between top and bottom, we are not talking about elements in between bottom and top. There is nothing to that makes sense of it, right? So if the top and bottom boundaries pass, sorry, oh, so I write this bottom. Now this is the top. Okay, so this is the top. So when they pass each other, there is nothing in between top and bottom, right? Because top is looking down, bottom is looking up. So will they ever have anything in between? No, right? They have crossed each other. So that's why it basically requires us to stop the execution. Okay. अब बताओ zoom. Yeah.
So इसमें while condition तब तक सही होती रहेगी जब तक कोई element बचेगा नहीं, है ना? और d की वैल्यू भी इंक्रीज होती रहेगी.
हाँ, d चेंज होता रहेगा, डायरेक्शन चेंज होता रहेगा ताकि हमें प्रिंटिंग आती रहे. While तब तक चलता रहेगा जब तक इन दोनों में से कोई एक एग्जीक्यूशन नहीं हो जाती, right? You can see they are basically telling us कि both the part, left and right part, and done with the printing, stop. Both left, top and bottom is done with the printing, stop. This is basically dividing the array in between two parts, right? If दोनों like designated pairs ने काम complete कर दिया, तो हमने पूरी array का काम complete कर दिया ना, 2D array का, right? If the entire top half and bottom half is completed, so I can say कि entire matrix is completed, right? Similarly, if the entire right and left is completed, I can say the entire matrix is completed, right? Got it? Okay. So yeah, Dharmendra, I was asking कि किस part पे zoom in करना है आपको assist के लिए? Zoom out it. Zoom out. I need assist. किस part का assist चाहिए? मुझे बताओ. आपको कोड अभी मैं दिखा दूंगा. कोड करते हैं इसको, ठीक है? थोड़ी सी लंबी होगी आज की क्लास, कोई बात नहीं. Question. Okay. Basically, while loop is preventing crossing. Yes, while loop is basically preventing crossing. Okay, please think it out, right? Ki what is like space in between and crossing wala part, right? Okay, so let's just quickly have a look at its code, right? It's a long code, so that's why let's have a look at it.
पहला क्वेश्चन देखा जब लगा हार्ड है, फिर कॉन्सेप्ट देखा लगा बहुत हार्ड है.
So can you share the note of this? यार इसका नोट कैसे शेयर करते हैं मेरे को आइडिया बिल्कुल नहीं है. अगर तुम मेरे को बता दो तो मैं कर. Right. Okay. So let's have a look at the code. Right. So this was the only part of taking inputs. Right. Apart from this, we build the entire algorithm. Okay. So let me just copy paste it, right, for the sake of saving time. Right. मैंने ही लिखा है. So I just wrote this code before the start of the class because I know the concept will take the entire time. So basically to save time, you can see I have D as the direction, T as the top, S as the start, and E as the end, right? Okay. So these are columns, top and bottom are the boundaries. Okay. So left and right, you can see in code, we are using the R as the boundary for the rows, for number of rows. So we can't use that parameter again. Okay. So that's why we are using two separate. Start and end are for column, right? You can see column start, start, column end. Okay. I hope this don't get any confusing, right? So again, see, if I zoom it in a bit, see, same while loop less than or equal to B, less than or equal to E, right? This is for top and bottom, left and right. Got it? And we have an and condition. Either of them gets invalid, so that basically tells us ki stop the execution. Okay. Apart from this, the entire code that I just wrote with the help of you guys, right? Printing if else, else if, else if, else if. So I hope this part is clear. We discussed it on the notepad, right? Any doubts in the while part, inside while part, if wala part, right? Any doubts in this? Okay, so let's have a look whether this code works or not. Okay, so let's just copy this. Let's try and run it. So you can see जो पहली printing हो रही है ना, that is from 1, right? So that's why we are having the left to right direction as the starting point, right? This is the point that I was trying to explain. See, the printing is not starting from 4. Even though if we start from 4, we can have a spiral print, right? It's valid. But as per the problem requirement, we need to start from the leftmost top left element, right? So that's why we need to start from the left to right reversal first. That's why D0 makes it left to right by default. Okay, so I have like also written the snapshots. If you guys require the code, I can share that. Okay, if you guys require the code, I can share it. Right, so let me know कि यहीं डाल दूं कि WhatsApp group में डाल दूं, कैसे आपको चाहिए. I can like share it in the Meet chat or like Zoom chat, or I can share it in the WhatsApp group that we have. How do you guys want it? If you guys want it, right? If it's not required, that's also.
So it requires and WhatsApp भी.
Okay, so WhatsApp पे डाल देता हूँ, ठीक है? अभी डाल दूँ. All right, guys, please have a look. I have shared it in the WhatsApp group. Okay. All right. So let's try and also submit it. Yes, it's passing all the test cases. Okay. So yeah, as per the homework for tomorrow's class, please go through with this problem, right? I know this is a pretty tricky problem, but I hope you guys learned something. try to now what you guys can do to basically learn is okay, I basically tell you all the entire concept in code. Now just try to redo that concept, try to build the same concept on your own, right? Whether you are like able to figure out each minor detail that we do in the class, if that is if that thing you are able to do, you basically understood everything in this class. Okay, if you have any doubts, we can have again a discussion tomorrow, right? But this problem is a tough one, so please do a practice on your own. Okay, all right guys, so yeah, that's pretty much it for today's class, right? This was the longest problem that we have so far. Okay, so one more thing, did you guys like today's session with the all the pictorial representation rather than just coming in coding? Okay, so one thing is, if you guys want such a class key in which we can have like pictorial representation also, see what it happens is key we have a time foundation of 1 hour only, right? If you guys want कि आपको पिक्टोरियल रिप्रेजेंटेशन भी चाहिए साथ में, तो उसमें ना फिर टाइम क्लास एक्सटेंड होगी, राइट? जैसे आज हुआ कि 1.5 घंटे की क्लास होगी, राइट? सो इट कैन गो फ्रॉम 1 to 1 hour 30 minutes और समटाइम्स 2 hours if the problems are long. So if you guys are up for it, if you guys are willing to sit for 1.5, we can have like discussion on the notepads, right? But if we like keep in mind the time constraints that we have to complete the answers in 1 hour, so that basically bounds me to complete the code first, right? So that guys can see how to code. Okay, so I will be needing your support also if you guys want such a class, right? For today's class it was necessary, right? अगर मैं यही concept आपको console पे समझा रहा होता, अब 5 मिनट में निकल जाता, भाई कुछ नहीं समझ आ रहा, right? So that's why we had a long class today, right? So I hope you guys are comfortable with it, right? Please let me know. Okay, so yeah, guys, please try and practice on your own, right? I can basically teach you algorithms, but there are some concepts that you have to sit on your own and try to figure out कि अच्छा हो क्यों रहा है, right? You can hear it out from me, we can have a discussion, but some things you need to like give it a practice on your own. Okay, for tomorrow's class, we will be doing with strings, right? I guess strings assignment is pending, so we will be going with strings now. Okay, arrays, 2D arrays are done. Okay, so yeah, so that's pretty much it for today's class, right? I hope you guys enjoyed it. We will be meeting tomorrow, right? Tomorrow is Friday, right? Yes. So, all right, guys. So that's pretty much it from my side. Okay.
Okay, sir. Good night.
Yeah. Good night, guys.